to dry storage casks or reprocessed. Uranium resources. Uranium is a fairly common element in the Earth's crust. It is approximately as common as tin or germanium, and is about 40 times more common than silver. Uranium is present in trace concentrations in most rocks, dirt, and ocean water, but is generally economically extracted only where it is present in relatively high concentrations. Uranium mining can be underground, open pit, or in situ leach mining. An increasing number of the highest output mines are remote underground operations, such as McArthur River Uranium Mine in Canada, which by itself accounts for 13% of global production. As of 2011, the world's known resources of uranium, economically recoverable at the arbitrary price ceiling of 130 per kilograms, were enough to last for between 70 and 100 years. In 2007, the OECD estimated 670 years of economically recoverable uranium in total conventional resources and phosphate ores, assuming the then current use rate. Light water reactors make relatively inefficient use of nuclear fuel, mostly using only the very rare uranium-235 isotope. Nuclear reprocessing can make this waste reusable, and newer reactors also achieve a more efficient use of the available resources than older ones. With a pure fast reactor fuel cycle with a burn-up of all the uranium and actinides, which presently make up the most hazardous substances in nuclear waste, there is an estimated 160,000 years worth of uranium in total conventional resources and phosphate ore at the price of 60 to 100 US per kilograms. However, reprocessing is expensive, possibly dangerous, and can be used to manufacture nuclear weapons. One analysis found that uranium prices could increase by 2 orders of magnitude between 2035 and 2100, and that there could be a shortage near the end of the century. A 2017 study by researchers from MIT and DOI found that, at the current consumption rate, global conventional reserves of terrestrial uranium, approximately 7.6 million tons, could be depleted in a little over a century. Limited uranium-235 supply may inhibit substantial expansion with the current nuclear technology. While various ways to reduce dependence on such resources are being explored, new nuclear technologies are considered to not be available in time for climate change mitigation purposes or competition with alternatives of renewables, in addition to being more expensive and require costly research and development. A study found it to be uncertain whether identified resources will be developed quickly enough to provide uninterrupted fuel supply to expanded nuclear facilities, and various forms of mining may be challenged by ecological barriers, costs, and land requirements. Researchers also report considerable import dependence of nuclear energy. Unconventional uranium resources also exist. Uranium is naturally present in seawater at a concentration of about 3 micrograms per liter, with 4.4 billion tons of uranium considered present in seawater at any time. In 2014, it was suggested that it would be economically competitive to produce nuclear fuel from seawater if the process was implemented at large scale. Like fossil fuels, over geological timescales, uranium extracted on an industrial scale from seawater would be replenished by both river erosion of rocks and the natural process of uranium dissolved from the surface area of the ocean floor, both of which maintain the solubility equilibria of seawater concentration at a stable level. Some commentators have argued that this